Welcome to this Expert Insight. I'm Sherry Trigg, Editor and Director of Content with Medical Design Briefs, and we're here with Shane Wood, Director of Technology Polymers, and Dean Burke, Business Development Director at Confluent Medical Technologies. They will talk to us about a game changer for catheter manufacturing, a breakthrough material that delivers nearly twice the strength of traditional polyimide, providing unmatched performance and design flexibility. So can you each start by telling us a bit about yourself and your role at Confluent?
Yeah, I can start, Sherry. So my name is Dean Burke. I'm the Business Development Director at Confluent. I'm based here at the Chattanooga, Tennessee facility where we focus on film cast technology. So Teflon liners, polyimide tubing, variety of braided and coil constructions, and also balloons and balloon catheters. In my role, I work on the commercial side of the business. I help our sales directors identify, scope, and ultimately quote product for our customers. I think one advantage being here on site is because our sales team is all remote. I'm kind of the liaison between our engineering and manufacturing staff. But good to be here with you today.
Thank you.
And Sherry, I'm Shane Wood. I'm the Director of Polymer Technology for Confluent Medical. Primarily act in two capacities. One, I provide the engineering leadership for the Chattanooga site here with Dean. And then I also work with our various subject matter experts to identify technology priorities for our various businesses, including film cast, extrusion, balloons, and complex catheter businesses. So thank you for having us.
Excellent. Thank you. So diving in, so ultra polyimide offers nearly double the strength of standard polyimide. How does this innovation enable the design of smaller, higher performance, minimally invasive devices?
Yes, Sherry. So as you know, and probably your viewers know, polyimide is used in medical device manufacturing for a number of reasons, including thermal stability, chemical resistance, insulative properties, and as you mentioned, in many cases, it's for mechanical strength. The ultra polyimide that we've been working on does bring approximately twice the strength of standard industry polyimide, and what that allows is it allows for thinner walls for the design team while still maintaining the mechanical integrity of the tube, and that allows for more design cross-section to be used for other purposes that may be coil or braid reinforcement, or for a larger lumen for improved tool passage or fluid flow, for example.
Oh, excellent. So with the increased tensile and column strength, what specific improvements can medical device engineers achieve in catheter, guide wire, and delivery system designs using the ultra polyimide?
Yes, Sherry. So, Shane kind of alluded to it, but the thought process behind our ultra polyimide was that it's higher strength. It meant that the tubing walls could be thinner, but achieve the same performance. In minimally invasive procedures, these thin-walled high-performance tubing, it's often used as a conduit. These passages, they can carry a variety of different things, such as guide wires, biopsy tools. They can provide support for mechanical thrombectomy devices, or as Shane alluded to, they can be used for fluid transmission or for suction. So the merits of this ultra polyimide is twofold. When you have a larger lumen, it gives more clearance to those tools that I mentioned. It would also give you increased flow rates for either suction or materials. And then on the flip side, if you're trying to reduce the overall French size of the device, it could also be helpful.
So medical device engineers often face trade-offs between strength, wall thickness, and manufacturability. How does the ultra polyimide help mitigate these challenges, and what new design possibilities does it unlock?
That's a great question. I think the key word in your question was trade-offs. So generally speaking, some attributes are at odds. So for example, a stiff tube, it will not have a good kink resistance. But conversely, a flexible shaft, it would not be good with regards to column strength or pushability. So what I tell customers all the time, the beauty of our film cast process is it lends itself well to composite construction. So when you think about it as a whole, there are two liner materials that we can apply, Teflon and polyimide that we're talking about. You have the ability to add braid or coil reinforcement, and within that, you have a variety of different stainless steel sizes, both round and flat. You can also vary the coil pitch, the picks per inch from a braid standpoint. And then from an outer jacket perspective, you can go back over that with polyimide or a variety of different thermoplastics, such as P-backs or thermoplastic polyurethanes. So when you think about that, there's just a myriad of different possibilities that a design engineer can use. So with the launch of our ultra polyimide, we're actually giving customers now 2 different options that have different performance characteristics. And I think this is important so that they can kind of hone in on the optimal performance. They want to distinguish themselves in the market where there's a lot of competition.
Right. Right. Well, now, so with ultra polyimide's REACH compliance and restricted substance-free manufacturing process, what advantages does this bring to medical device developers in terms of regulatory compliance and even long-term supply chain sustainability?
Yeah, I think we have some great benefits there, Sherry. As you guys are aware, Confluent Medical was the first to introduce a REACH compliant polyimide formulation to the market in June of 2023. And tubing manufacturers historically have had various approaches to this compliance dilemma. Our approach has always been the easiest pathway for our customers, easy compliance with no restricted substances. This has become even more important as environmental scrutiny also in the U.S. has ratcheted up with regard to NMP, or the main solvent utilized in polyimide manufacture. So again, our REACH compliant offering on our original polyimide, has no restricted solvents, no supply chain uncertainty associated with those solvents, and also no extensive or expensive testing for our customers. That's been so well received in the market that we decided to incorporate that same philosophy with our ultra polyimide offering. So it is also being offered with no REACH restricted substances to make it easier for our customers.
Absolutely. So in terms of mechanical performance, how does ultra polyimide compare to alternative high performance polymer materials used in medical tubing, such as PEEK or PTFE? Are there specific testing methodologies that you've used to validate its superiority?
Yeah, I think that's a good question. A lot of times Dean and I are asked about better materials or maybe a better manufacturing process. And we've always tried to make it less about what is better and more about using our experience and our material science expertise to provide the best solution for the customer for their specific challenge. And that can mean different manufacturing processes or materials in different cases. PTFE, PEEK, polyimide, and a number of other materials, some of which Dean mentioned earlier, are well suited for a variety of medical device applications. As you know, PTFE is the gold standard for lubricity, and oftentimes the design engineers integrate that into the design for that reason.
Yes.
But it's also good for applications requiring high temperature stability. It's important for its inertness from a chemical perspective, and it has high flexibility for neurological applications. In contrast, PEEK and polyimide, they're typically used for very different purposes, often having requirements to do with strength, like you've mentioned. PEEK is typically important for its toughness and its ability to be well suited for long-term implantation, whereas polyimide may be a better fit for applications needing flexibility, high temperature exposure, and maybe dielectric strength. Oftentimes you asked a little bit about testing. So there's a variety of testing we can perform, but oftentimes we perform our initial characterizations with tensile testing. That gives us a good picture of a lot of the performance attributes that we're talking about: elastic modulus, elongation, things like that. So there's a variety that we can use, but that's one of the mainstays of our characterization process.
Excellent. Interesting, very interesting information. So given the continuous evolution of medical device designs, what further enhancements or next generation developments do you foresee for polymer tubing materials beyond ultra polyimide? Are there new material properties or manufacturing techniques that Confluent Medical is exploring?
Yeah, I'll take that one, Sherry. So here at Confluent, we hang our hat on innovation, and I'll give Shane and her engineering team a lot of credit. They are constantly working on improvements, not only to our equipment, processes, and material. And I think you mentioned that earlier, bringing REACH compliant polyimide and REACH compliant thermoplastics, as well as the ultra polyimide that we've been talking about today. So they don't just stop there. We're continuing to innovate. They've got several other things in queue. One is Teflon offerings. We also have some process improvements that should improve the surface adhesion for polyimide tubing. And then one big hot spot or topic in the medical device market is lubricious non-PFAS alternatives.
Yes.
So they're actively pursuing those, and we should probably in the next month or so be making an announcement about a new Teflon offering.
Excellent. Well, thank you both for joining me today and providing your insights and your expertise. It was a pleasure to have you.
Thank you so much.
Thank you, Sherry. We appreciate you guys having us.